probability, the last part. Conditional probability. Conditional probability is the probability that an event A occurs when it is known that another event B has already occurred. And then how do we write it? Notation will be P brackets A little bar and B. Okay, so the first one is what's about to happen. B is already happened. So the B is the event that already happened. Event A is about to happen or happening, about to. Okay, and then there's a formula for this. Now there's a bit of a proof there, and I'm just going to leave it, and you probably will understand what I mean by that. And example, okay, question 1. Let's see if I can put it in. In a group of 100 year 11 students, 40 students are taking maths, 30 students are taking biology, and 20 are taking both. If a student was chosen at random and the student is taking maths, like, you know, he or she is already taking maths, what is the probability that the student is taking biology as well? Okay, so first thing first, I would actually sketch Venn diagram. I like Venn diagram. It's not easy to draw sometimes, but it's not too bad. So that's a maths and that's biology. And we know that both 20 of them is both taking it. And there's a 40 student taking maths, 30 student taking biology. When you add all this together, you get 90, wouldn't you? So there's a 10 students who doesn't even do biology or maths. That's fair enough. Okay, so that's what I've got. Now, I read the question. I know what the question is asking me to do. We are looking for this. So, what does it mean? It's a conditional probability. So, maths is already taken. And what is probability of that person is also taking biology? So, that's probability, conditional probability. So, that's my formula. So, now I need to think about how am I going to write the solutions on this. So, I need to find probability of, and also, I mean, it's all there, so it's not too bad. That's a 20 here, maths is 40. So here, I'll just go 20 over 40, half. All right, so that's done. That wasn't too bad, wasn't it? So that was good. Next one. In a game of cards where the winner is determined when a player gets 2 cards of the same suit, okay? So it's like heart, heart, diamond, diamond, and so on. Tim draws a card and gets a diamond. What is the probability that the second card will also be a diamond? So this is a conditional probability. So we're going to have to go probability of, I'm going to call, he got the first one as a event A, the second card, event B. Okay, so I'm going to go B and A. Okay, so A is already picked up as a diamond. We were looking for a probability that it's going to be diamond again. So I'm going to go like that. So I need to find, so how am I going to do this? All right, there's a couple of ways we can find this. This is in a product rule, so which is B, A. So what was the probability of getting a diamond? There was a 13 of them, 52 for this one. And the second time getting it, it would be obviously 12 out of 51. Yeah. That's not too bad. 1 over 17. Okay, just think about that, guys, because you took out the diamond already, so the total number will be 51. And then the other one, the suit, for diamond suit, is 12 left. And therefore, so that's 1 over 17. And then probability of A will be just same as that, 13 out of 52. Now this one, you can write it like this if you want to. If you don't feel comfortable writing it 2 decimals like that together, you can do that. I mean, you can, calculator can do it this, so you don't have to worry too much. So our answer is 4 out of 17. Okay. Alright, so next part, little part now, is a conditional probability and independent events. Now these are all the formulas that we probably have to memorize. You know this one. And this one, let's have a look at this proof we're going to get. So the conditional probability that B is already happened, A is about to happen. So that's the formula. Now, if I times this together and make the A intersect B is a subject, it's like that. And A and B, if A and B are independent events, we can of course use the product rule there. So I'm just replacing this with this. Okay, so I'll put that in there and there. Now equating them together, I can tell probability of A is same as probability of the conditional probability. Okay, so that's I can say. And then similarly, I can say the same thing. All right. So example 1. Okay, so it was given probability of event A is 0.3 and probability of A intersect B is 0.06. Determine whether A and B are independent if. That's that. Okay, so let's have a look. For independent events, the product rule is, so I'm going to go A intersect B equals times B. Okay, so that was 0.06. Nah, that's not the same, isn't it? That's not good. So therefore, A and B are not independent because they're not the same. And B, when it was 0.2, so let's have a look. P, same. No, this time it's 0.2. Okay, the P is 0.2. So 5.3 times 0.2. Yeah, so 0.5 there in the question, and it was 0.06, and it is. Yep, bingo. So therefore, A and B are independent. Okay, so that's what it was. Now, second one, it says show that. Sort of like a proof. X and Y are independent given that all this information. Okay, so we need to prove this. So I might just use different color. So B. Alright, so I'm going to use P, X union Y equals, what was the formula? For that was independent minus X intersect Y. Okay, so it was given to us, all this, so I'm just going to write it. And we don't know this. So if I want to make P X intersect Y, I'll go So I'm just writing it here. Px intersect y equals 0.35. Okay, now if it was independent, I could say equals, what was the formula? X times py, wouldn't it? And what was a px? It was 0.7 times 0.5, which is 0.35. So x, y, look at that, that's the same as this, as required. So therefore, I can say A and B are independent events. Excellent. So that's what it is. Now, it might be a little bit of confusion because it's a conditional probability. Actually, it's a part of your 10 course, but we probably didn't go through it enough. But make sure you watch this more than once and understand fully. Okay? Well done.